In this video, we're going to be taking a look at a visual trace of merge sort. So over here, right, we have kind of our standard input we had before, which is going to be a randomly ordered input. The hope is, right, this is looks somewhat like the average input that you'd give it if you're running in a real program. So before I click play on this, maybe think to yourself, how will it look? What do I expect to see shuffled around? One maybe caveat there when you're trying to visualize that, remind yourself that right now this algorithm isn't set up to be run in parallel. It does basically one thing at a time. All right, let's take a look. So here, right, notice it's starting on the left-hand side. And you can see the chunks already. The first ones right, were kind of small, but you can see, right, it's built basically a sorted left-hand side. Now it's building smaller sorted regions, combining them. It goes kind of fast. Let me try to go back again. Although kind of watch this carefully, right? Somehow the idea here, right, is that all those breakdown steps, we don't even really see them here because there's no elements moving. It's only once we get down to really, really small sizes, right, once we get down to an element of size 1 that we start to move things around, and that's actually where it'll show up on the visualization. So on the left side, right, we see some work, right, where we built really quickly, right, a sorted subregion, another sorted subregion of the same size, right. We basically sorted the entirety of the left, now we're doing the entirety of the right. It's kind of spanning left to right just because there has to be some order. And yeah, there we go. So again, right, what you saw is that initially, right, it was basically working on like this half, right? And then it was, within that half, right, it's working on the half of that, right? It basically ends up, working right here at kind of that leftmost element and combining it with the next leftmost element, right? And then these two get combined with these two, and then these two are active, right? And then these get combined. That's why it kind of goes from left to right, right? So notice we're doing a little bit, a little bit to far left, and we go to a little right a little bit, do a little bit of work, right, and then combine them together, right? That's basically just the flow of it doing one thing at a time, going from left to right. All right, so this is our merge sort algorithm. Let's take a look at one more possible input. So this is reverse order. Okay, so yeah, and this I guess makes the pattern look a little bit more clear. So you can see those chunks, right? Those little vertical things are spiking out, right? You can tell those are the active regions that are sorted, right? They start really small and they grow larger as you merge them together. All right, quick question for you guys. Which of these was faster, right? Or were they maybe the same? Well, turns out they actually were pretty much the same speed. And this is something interesting we're going to see from merge sort, is that it's reasonably stable when it comes to performance. Insertion sort, I had the deal where it's like, well, if it's unsorted, it'll look like n squared. If it's nearly sorted, it'll look like n. Merge sort doesn't do that. Okay, merge sort is basically always going to look like n log n. Okay, so that's actually a rather nice thing because it gives us some certitude of how long it'll take to run, right? We don't have to worry that it'll take too long, right, or too fast. It'll always be about the same. All right, so that's what we got for the sort. In the next videos, we'll start taking a look at the source code of this algorithm.